Good morning, everyone.
Sir,
Good morning, sir.
Good morning. Am I audible?
good morning, sir. Yes, sir, you are audible.
So, what we are going to discuss today is very, very important for all competitive exam, GATE exam, everywhere, and for practical purpose also. And this will continue for whole year course. If you don't know about this, then in coming semester you may face problem, or maybe in some other subject also it will be repeated again. Can I start?
Yes, sir.
So, the name of this topic is subnetting. You heard this term earlier somewhere? Subnetting. Did you heard somewhere in some other subject? No. Okay. So let me start with a question. Suppose we need to construct a building and I want to construct that building without any floor, just the top and the bottom. Prostuti, any problem? Please.
Sir.
Okay. So I want to start a building without any floor. That means there is no floor, first floor, second floor, third floor. There is no floor. I construct a very large building. Is it clear? I want to make a large building without any floor, without any room. Okay, only height and top and the bottom. Do you think it is useful for us that building? Tell me yes, no. If the question is clear to you, I want to construct a building without any floor, any room, only bottom and top. That means only height is will be there. Height will be maybe fifth floor height. That in between there is no floor, no roof. Do you think this is useful for us, that building?
Noiseful.
No. Okay. And what we have to do then? We have to make some floor, then we have to make some room as per our convenience. It may be suppose five floor, then each floor have some room for kitchen, some room for bedroom, some for drawing room, whatever. Okay, that means we have constructing that building with some floor and with some room as per our needs. Okay. Now come to this topic, subnetting. Why we need to go for subnetting? This is related to IP address. Obviously, we are discussing IP address. As you know, a IP address have two portion. One is network portion and another is host portion. Okay, one is network and another one is host. If I compare this network portion as a building, what I want to construct without any floor, that type of things. For example, if I have a IP address of class A, that means our network is 255.0.0.0. That means first 8 bit always fixed. Okay, we cannot make some partition on that. It's a big things, big network. Class A is a big networks because we can create 8 networks, not 8 actually, 2 to the power 8, that much of network we can create. Okay, for example, if yesterday I talk about the IP address of downtown university, if I buy a IP address from service provider, that means I'm buying only one IP address, but I have lots of computer in my campus or in my building or in my university. So somehow we have to make more IP address, we have to make or we have to generate more IP address from that IP address which we brought from service provider. That means from one IP address we need to generate thousands of IP address for our internal computers. Okay. So for this purpose we have to subnet. We have to do subnetting. So if I want to define what is subnetting, I have to define like this. Subnetting will do or will separate small net to subnetworks from a large network. That means from a large network like a building, whole building without any partition, we have to make small floor, small room for our own convenience. Like that, a large networks when we divide it into smaller groups, it's called subnetting. Is it clear? Big networks divided into small networks. Alright, those networks called subnet. Subnet network you can say. Large networks is divided into smaller networks. That process is called subnetting. So it is written here, subnetting allow you to create multiple logical networks that exist within a single class ABC networks. If you do not do subnet, you are only able to use one network, that means a large networks. If you don't do subnet, you are only able to use one networks from your class A, B, C. That means A is a network, B is a network, and C is a network will work if you don't do subnetting, which is unrealistic. Obviously, if we will not do subnetting, then we have only big three networks with us. We cannot go for more computers. We have to buy thousands IP address for thousand computers if you will not do subnetting. But it is not, or it is unrealistic. You cannot buy thousands IP address from service provider. Otherwise, if you have to buy thousands IP address from service provider, lakhs of money you have to spend for this. So each data link on the networks must have a unique network ID. Okay, every networks have a unique network ID. Like I already mentioned, IP address is two person. One is networks, one is host. So each and every data link, each and every network device have a unique ID, unique network ID, with every node on that link being a member of the same networks. If you break a major networks, for example class ABC, into a smaller subnetworks, what you can do if you break it, it allow you to create a networks of interconnecting subnetworks. That means we are making a large network into smaller networks. Maybe from one networks we are making 10 networks, 8 networks, whatever. In order to subnet a networks, extend the natural max. Natural max, I am talking about the subnet max. In the first or two second class, I think, when I was discussing about IP address, I was discussing about the subnet max 255.0.0.0. I think you remember 255.55.0.0, 255 to 55 to 55.0. This was the natural max. In order to subnet a network, extend the natural max with some of the bits from the host portion of the address in order to create a subnetwork. That means how we'll do subnetting? We'll borrow some of the bit from the host portion. We have two portion, one is host, one is networks. So we'll borrow some of the bits from the host portion and then we'll do the subnetting. So if we'll talk about the class C address, so we have how many bits per host? 8 bit, 24 bit is per networks. So out of this 8 bit, we can borrow some of the bits for subnetting. Is it clear to you this slide? Right? Yes, no. Anyone, any doubt? Okay. If no doubt, no sir. Not understood? No doubt. Oh, no doubt. Okay. So we'll go for the next slide. What to repeat? Okay. This slide is talking about subnetting. Subnetting is nothing but a large networks divided into smaller network. Like where a large building we are making smaller floor or smaller room, like that. A bigger things making smaller, that is subnetting. Okay, a large networks divided into smaller networks for our own convenience, that process is called subnetting. Okay, how will do subnetting? As you know, there are two portion of the networks. If I talk about class C networks, 24-bit was for network ID, 8-bit was for host ID. So we'll do what? We'll borrow some of the bit from host ID and do subnetting. That is the process. In the next slide, I'll show you how to do. Okay. So this is the example. This is class C networks. Okay. Class C networks and IP address I'm taking 204.17.5.0. 204.17.5.0. Since this is a class C networks, the subnet mask obviously what? 255.255.255.0. Yes, no. Class C default subnet mask 255, 255, 255.0. Yes, that is default. When I talking about class C, how you can say class C? Because it is 255, 255, 255. That means this much of 1, 24 bits 1 and 8 bit 0. So this portion is network. Is a big networks 204 17.5. Yes, default. So this is, you can think as a building of this. A building is of this type without any floor. Okay, this is the big networks. Our task is to create some floor or some room. We'll create some floor from these networks. Okay, for example, this is our downtown university IP address. तुम लोग कुछ डाउट होने से बोलना, ठीक है? If any problem, any doubt, you can raise question. Okay, so this is the downtown university IP address, for example, and this is class C. How we can say class C? Because the subnet mask is 255, 255, 255.0. Okay, so if I convert this into binary, it's become this one. You can see 204 is nothing but this much, this 8 bit, 17 is this much, 5 is this, and rest 8 bit 0. This is the binary representation of this IP address. Okay, so I will borrow, this is network ID and 8 bit is 8 bit is host ID. This 8 bit is host ID. This 24 bit is network ID. How we can say? Because these all are one. Okay, so my intention is we will go for subnetting. That means we want to create more IP address from this IP address. What was the IP address? 204.17.5.0. I brought this IP address from service provider, and I have some more computers at my building or at my campus. So I need more IP address which is related to this IP address. Okay, so what I will do, I will borrow some of the bit from this person. So here I am borrowing 3 bit out of 8 bits. I am borrowing 3 bits, and we are making those 3 bit 1. You can see it is written in green color. Is it clear? Out of this 8 bit, I am borrowing 3 bits and it makes whole 24 plus 3, 27 1. It's now 27 1. That means that was that much we can consider as a network ID now. And here this 3 bit is for subnet. So now that IP address is divided, it become three portion. One is network portion already we have. Then in the middle one, this is your subnet portion, and rest of the 5 bit is for host. So now tell me, right, how many bits for network address, how many bits for subnet address, and how many bit is for host address, right, in the chat box. Network, subnet, and host. If I borrow 3 bit from the host, how many bit is left for host? Right in the chat box. नेटवर्क आईडी के लिए कितना बिट है तुम्हारे पास, सबनेट के लिए कितना बिट है, और होस्ट के लिए कितना बिट है. Right in the chat box. 5 is left for host, right? Is it clear, all of you? No, sir. Okay. Yes, sir. Junumoni, can you explain to some others who is not understood? Junumoni, switch on your mic and explain so that other can understood.
Yes, sir.
Yeah. Listen, everyone.
Sir, here networks are in 24 bits and we are borrowing 3 bits from the host for
Yes.
subnet.
Yes. Okay.
5 bits left for the host.
Yes, that black color, earlier 8 bit 0. Now we are borrowing 3 bits by making it green, and we have 5 bits for host. Earlier 8 bit was host. Now we are borrowing 3 bits from 8 bit. 8 minus 3, how much? 5. So 5 bits. Is it clear now, right? Yes, no? Those who was right, no, now, right? Why we are borrowing? Yeah. Why we are borrowing? We are making a large network into smaller networks. With only one IP address, we cannot run downtown university because we have lots of computers. We have to give each and every computers a IP address which will be related to this IP address so that we can get internet on those computer also. Because service provider will provide only this IP address to me, I cannot buy thousands IP address from service provider. Okay, so I have to make some others IP address. I have to generate some others IP address from that IP address. Nothing is clear, I think. Okay, so that's why we're making subnetting. That's why we're borrowing. We have 8 bit is for host, but we don't want that much of bit for host. We, that's why we're making some of the bits as subnet. Hope it's clear to you, all of you. This topic is not too easy. I'm taking time. So if you have doubt, you can ask. Anyone, any doubt? Okay, no sir, no doubt. Okay, go for next slide. So it is written the previous things only here. With this 3 bit, with this 3 bits mean those green bits, what we are borrowing from the host. So it is possible to create 8 subnet. Obviously 2 to the power 3, how much? 8. Yes. Now we are talking about we are creating 8 floor of that building. Remember, we are taking example of building without any floor earlier. Now your building name is 204.17.5.0. Okay. So that building I am making 8 floor. How? By borrowing 3 bits from the host. 2 to the power 3 is 8. So that's why I'm writing here with these 3 bits it is possible to create 8 subnet. Is it clear? This line? Right? Yes, no, or you can speak. First line is clear? Yes. No, sir. No. Okay. In the previous slide, we are borrowing 3 bits. Those 3 bits. These 3 bits. I'm talking about those green 3 bits. Okay. So from 3 bits, we can generate 8 network ID. 8 subnet. How? Because 3 to the power 2, sorry, 2 to the power 3 become 8. As of now you just try to understand, if we have 3 bits we can generate 8 subnet. How? Because 2 to the power 3 is 8. Is it okay now? When I'll take example it will be clear. With remaining 5 host ID bit, obviously out of 8 we take 3 bits, so it become 5 bits. With remaining 5 host bit, each subnet each subnet means there's 8 subnet now. 8 subnet. Remember, very carefully listen this line. With remaining 5 bit host ID, that means with remaining means those 5 bits, these 5 bits. I'm talking about these 5 bits. 3 bits per subnet, green color. 5 bits is for host. So I'm now writing here with the remaining 5 host bit, that means those black bits. Okay. Each subnet, how many subnet now we have? 8 subnet, because we can generate 2 to the power 3 8 subnet. That means each and every subnet can have up to 32 host address. With the remaining 5 host bits, each subnet, if subnet means there is 8 subnet, I can compare there is 8 floor now on that building, and each floor 8 floor में हम लोग 32 रूम क्रिएट कर सकते हैं. Is it clear now? each and every floor we can make 32 room. Is it clear? We have 8 subnet to the power 5 equal to 32. Yes, we have 8 subnet. Each and every subnet means routing. With remaining 5 host ID, that means 5 bits. Each subnet can have 32 bit, 32 hosts. If I talk about the building, we have 8 floor now. Each and every floor we can make 32 room. How? Because we have 5 bits. 2 to the power 5 is 32. We can calculate 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32. So each and every subnet have now 32 host address. Yes? Is it clear this line? Yes, no, right. We have 5 bits. 2 to the power 5 is 32. If I compare with the building, we have 8 floor. So each and every floor we can make 32 room. Okay. So if I compare with the networks, each and every network, so each and every subnetwork have 32 host. Host is compared with the room. Is it clear? I'm comparing the host with that room. Hope it's clear. Those who are trying to understand, it is clear. Yes, good. Can you explain? Anyone explain what I try to talk about? I want to listen from you. Anyone? Repeat one times, okay? So we have remember we are borrowing 3 bits out of that 8 bits. So 3 bits from 3 bits we can create 8 subnetwork. 2 to the power 3, 8 subnetwork subnet, and rest is we have 5 bits. So 5 bits we have for host. So we can create 2 to the power 5 32 hosts in each subnet. If I compare these things with the building, that building have now 8 floor. Each and every floor have 32 room. So how many room we have now in whole building? Can you calculate? Tell me. Each and every floor have a 32 room. We have 8 floor. How many room we have on the, and how many host address in that building? Write in the search box. 256. Right. That is total 2 to the power 8 is 256. We have 8 bit. Okay. That means 256 room we can generate. तो देखा क्या किया हमने. So एक आईपी एड्रेस खरीदा था वाई सर्विस प्रोवाइडर से. वो क्या था 204.17.5.0. We are making now 256 host address. That means 256 कंप्यूटर को हम लोग आईपी एड्रेस दे सकते हैं. कहाँ से बनाया? जो आईपी एड्रेस हम लोग खरीदा था उससे 256 आईपी एड्रेस हम लोग बना लिया खुद के लिए. Is it clear to you? Right? Yes, no. Yes. Okay. Now, see here in the next line. It is written after comma. It is written 30 of which can actually be assigned to a device. 30 of which can actually be assigned to a device since host ID of all 0 or all 1 are not allowed. It is very very important to remember this. That means each and every floor, the first room and the last room we cannot use. Remember, the first room I am talking about all 0, 0.0.0, that means all 0. 1 minute. Hello, hello. हाँ 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 बोलिए। हाँ ठीक है ठीक है। जो चाहिए आप जो चाहिए वो भेज देने से मैं दे दूंगा। ठीक है उस टाइम। Okay, so what I'm trying to say, the first room and the last room you cannot use. First room means all 0 and last room means all ones. That means 32 1 and 32 0 you cannot use. So कितना रह गया? So each and every floor से कितना माइनस करना है हम लोग को? How many room we have to subtract from 32? Not 16. 16 कहाँ से आ गया? Oh, total. Okay, total. Okay, 8 into 2. Uh, total 16. That means each and every floor से हम लोग को एक एक दो एक टू माइनस करना है. So 32 minus 2 is 30. So सब फ्लोर से हम लोग 30 रूम ही यूज कर सकते हैं. Okay, that means we can use 30 host address out of 32. Now not 32. Now it's 30. Okay, so each and every subnet have now 30 hosts, not 32, because we cannot use the first address and the last address. Is it clear to you? Right? Yes. Okay. So why we? No one asked me that question. Why we subtract those two? Where those IP will be gone? कहाँ गया वो एच IP address? Do you have this question in your mind? जो दो दो सब्सट्रैक्ट किया क्यों किया? वो कहाँ गया? So that can be also used for some other purpose. So each and every network, that means I am now talking about subnetwork. Each and every subnetwork have two IP addresses reserved. So each and every network have two IP addresses reserved. The first IP address is reserved for network ID, or you can say subnetwork ID, and the last address is reserved for broadcast ID. Broadcast means, I think television or TV is broadcasting. That means one sender, lots of receiver. When we send something from one sender and lots of others receiver, that process is called broadcasting. So first ID is used for network ID or subnetwork ID, and last address is used for broadcast ID. So if I compare with that building, each and every floor have first room is, you can say, the room ID, and last address is broadcast ID. Okay, is it clear? Network ID, first address, last address, broadcast ID. So like this, in each and every subnet have two IP reserved for these two purpose. Okay, any doubt? I have only 5 minutes. So this is the scenario. We'll repeat this slide again in the next class. So this was our IP address 204.17.5.0. Okay, this is the network address of the first block or first subnet. We have 8 floor. I talk about the 8 floor. See, count 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 floor I'm talking about. These are the 8. Now you new ID, network ID. This is the first address of the first floor. This is the first address of the second floor. This is the first address of the third floor, fourth, fifth, sixth, seventh, eighth. What I was talking about in the last slide, that means the first address. This is the first address. 204.17.5.0 is the first address, and this is reserved for network. That means you can say this is identify that floor. Okay. If I reserve this first ID, that means 204.17.5.0, what is the next ID? Next ID will be 204.17.5.1. And how many room here? We have 32 room. 1 is already minus, 0 is minus. So it will go up to 1 to 30. It is written here 1 to 30. I can show you. I'll repeat this slide in the next class. So your IP was 204.17.5.0. This was the IP address. So from this IP address, we have to make 256 IP, and each and every subnet have 30 IP address for host and 2 IP address is reserved. The reserved IP address will be in the first block this one, and the second one will be 204.17.5.31. Okay, so 0 to 31 is 32. There is 32 numbers. In between what are the IP address? 4.17.5.1, and it will go up to 204.17.5.30. This is clear, I think. This 30 bit is for host. I am talking about at that time. Okay, this is the network ID. This is your network ID for this group, and this is your broadcast ID for this group. Okay, so this is your network ID first address as is reserved. I subtract this ID from the 32. So 1 to 30 is 30